So everybody, thanks for joining us all. My name is Phil Glennie. I am the Director of Marketing and Sales at Long-Term Technology Services. We're happy to have you join us today. Just a note for everyone joining that we are recording this session and we're going to make it available after the fact for people who weren't able to make it, and we will be sure to send it through to all of you as well in case there's anyone else on your team or in your network that you think would be interested in watching this after the fact. We know a lot of companies are busy these days, and so we're very grateful for your time today. Just a quick note about this session. It's a bit of a mixed audience for this session. This session is composed of people who are already familiar with the solution we'll be discussing, which is Dynmik Design for Die. And this is kind of going to function as a bit of a what's new session for those folks. And we've also invited folks who might not currently be using this software, but are interested in learning more about this realm of motion simulation, collision checking, clearance analysis, and things like that. So we've kind of tailored the presentation to serve both audiences. So hopefully, we hope that you'll get everything you need from it. But we'll also have a pretty robust discussion period at the end where you'll have a chance to really, give your opinions or ask any questions you might have about what you've seen here today. So with that said, most of you probably already know us and are probably pretty deeply involved with us. But for those who don't, I just want to let you know that at Long-Term Technology Services, our mission is to be a one-stop shop for digital industry solutions, and we help companies with software, consulting, training, everything you need from product design to manufacturing, into robot programming, plant simulation, production scheduling, you pretty much name it. And we're always up for a hassle-free chat. And we just love learning more about what's on your mind these days and where you want to go, either as an individual or as part of your team. We have a lot of experience in the tooling sector and complex design validations, simulation solutions. We're specialists really in that small to medium-sized company realm, and we really are dedicated to creating situations that work for you and for your company when it comes to these digital solutions. And as part of that, we're a very proud Siemens Smart partner and technology partner. And with that in mind, we're talking about a solution today that works in tandem with the Siemens NX CAD. So just a quick agenda for what we're going to be looking over today. As you just saw, I basically just went through the meeting introduction and the walkthrough. I am joined today, of course, by Chetan Gautam, who is my colleague here, and he will be showing us the solution itself in a live demo. Before that, I'll quickly walk through the general benefits of the Dynmik Design for Die, just as a foundational refresher for those who are already using it, and a bit of an introduction for those who are kind of coming into it new as well. From there, we'll move over to Chetan and the real sort of substance of the presentation, which is really that live demo showing you these new things that you can do with the software, and then we'll move from there into sort of a two-part conversation, which is hearing from people who are current users and reflecting on these new changes, as well as hearing from people who are new to it, and talking about even your wish lists or things that you would like to see added to this software going forward. And so a quick rundown here of benefits of Dynmik Design for Die. So basically the reason that we created this solution to add it on to NX CAD is really because we were looking for really easy to use motion simulation, clearance analysis, and collision checking. And we wanted it to be very, very useful to the die industry. So in other words, we wanted to really clean out a lot of the commands that are not relevant to the die industry. And we wanted to make it as streamlined as possible to help your die designers really test, improve, and validate those die designs really quickly. And in that process, we're hoping that we can reduce the number of design iterations that are actually needed because you're doing so much more in a virtual environment with the confidence that that's going to hold up to reality. Another interesting benefit here that we're going to talk a little bit about later is actually even using this software to think about your overall design process. The idea of, in your design stages, moving from strip to the transfer to the die. It's not always the case that people are designing their transfer prior to designing their die. But we are going to talk a little bit in this discussion period about, why that's a good idea and why this solution can help with something like that. Another really big thing is really easily exporting data to share with your press person who sets up the transfer. So really that sharing of information that's really going to help you streamline your processes and really introduce a lot of reliability, when you're moving things through different stages of development, all the way from design straight through to the shop floor into production. And one of the original reasons for creating this was to save you significant time and money by avoiding any sort of collisions on the shop floor without the need of really getting into a lot of physical prototyping. And with that, the hope is that you'll be able to tackle more complex designs with confidence and speed, knowing that any errors or any collisions you run into are going to happen in that virtual environment, not the real environment. As we mentioned, it sits very comfortably inside Siemens NX CAD. Its commands are tailored specifically for the die making industry, using a lot of common terms, commands that are going to be familiar to your designers. And this idea of it really kind of being the bowl of porridge that's just right for die designers, right? It's trying to find that middle ground between simulation solutions that are either they're just too simple, maybe too superficial, or unnecessarily complex. You don't necessarily want to throw your die designers into super complicated, CAE stuff. When you're doing this, you want something that those designers can do inside NX, in a reasonable amount of time, so it's actually saving you time. It's saving you effort. It's not adding effort. So with that, that takes us to our What's New section. And in this section, we're going to be talking about some of the things that are new in the latest update. And so we're going to start with, or Chetan's going to start by showing you a bit of the UI layout and some enhancements to that. So the reason we're starting with that is, again, because of the two audiences we've invited here today. Going through the UI will offer a pretty quick introduction into what the software looks like and what it's like to interact with it. But because there have also been some subtle changes, that's also going to be relevant to the people who are already using this software and already quite familiar with it. So we're hoping that by starting with that, that's a bit of a nexus that can kind of get those groups on the same page pretty quickly. And then we're going to move into some of the things, those of you who have used the software probably recognize some of these things because you have probably specifically asked for them, and these were created in direct response to those requests/demands. And so we're very, very grateful for your input and the input of the entire die making industry for these updates. One of the big ones, as you can probably see there, right, is SPM optimization. So the idea that you're using this software to optimize the motion parameters for the expected production rates you're talking about. And then from there, we're getting into lots more control with your collision checking, and especially this was a big ticket on some people's lists, right? This idea of minimum clearance zones, setting minimum distances between components, and then making sure that those are flagged when those conditions are violated in the validation or the simulation. And then from there, you're getting into tracking curves. You're getting into 0.1 motion simulation increment. This is moving from 1.0 to 0.1, so a 10 times finer control when you're controlling motions in the simulations. And then finally, the copy component, which is copying motion parameters for easy collision checking, and that's basically a big time saver and just helping with the whole user experience of this product. And so with that, that takes us into the first of these new sections. And it's at this point that I'll get us into the real substance of this presentation, which is my colleague Chetan providing the live demo of some of these new changes. And with respect to questions, please feel free to pose a question at any time in the chat box, and we can try to answer those as we go along, or we can just wait until the last third of the presentation, where we will have a more general discussion, at which point you can type something into a chat box, raise a hand, or open up your mic to pose a question or make a comment. So with that, I'm going to turn things over to Chetan to share screen and to bring us into the live demonstration.
Thanks very much, Phil. I hope you can hear me well.
Yep.
Yep,
it's all good.
All right, thank you very much for the introduction, and good afternoon, everyone. So I'll be taking this opportunity to present the new functions and features, and we'll start with the main interface, how it looks like now, what new buttons are there to press, for existing users, of course, and for those who are new, they're all new. So, all right. So at the bottom here, if you just see the big picture here at the bottom, this is one of the ribbon tabs that we have for our Dynmik Design. And we have added a few different buttons. So basically we start from initializing the project, the main interface, Dynmik Design. Then we have a couple of, three actually new buttons here, uh, basically functions, to put it the right way. So SPM optimization, that's one of the highlights. Mapping is kind of associated with this one. Then we have the Dynmik Design collision checking. So that's a brand new function as well. So basically you're getting two new functions on the main screen, of course, as a big kind of functions. Plus, once we get into the actual interface, you have a few different options too. Just as you see here, we have a new button here, copy components, then I have link components and tracking curve. So that's what these are. And so these would be additional enhancements that you'll be looking at. All right. So just kind of just to name a just to kind of give you an idea what these are actually doing. Let me take you to NX here quickly, and we will look at the results right away. So here, what we are looking at is this is the main interface that you see, right? So you need to have uh, this idea where it is exactly located. So initialize project, we have some enhancements there. Dynmik Design, I'll be opening this one up now. And plus these are the buttons that we were just talking about. I'll start with some of these the minor items in between, and then we'll see what exactly is happening. The big theme is definitely about is roaming around a few things. One is, of course, the collision checking, improving the collision checking criteria, and we are attacking that problem or issue from different angles, different functions. Then you have the SPM optimization on the side note. Then we have the background stuff that helps enable all of this, kind of a back-end fine-tuning some functions. That's what it is. But mainly two big areas, SPM and collision checking here to say. All right. So what you see is just in following up on the collision checking here first. So what we have is we have this kind of component here, right? That's a kind of copy component. That's what I'm kind of demonstrating right now. So this is kind of a big component, like a upper die, lower die, top shoe, bottom shoe. So these are the big geometry-heavy components when we define in our project. And previously, when you mount or define all those geometries on these components and try to identify the collision checkings, it was kind of tricky to deal with them because there was a lot of geometry on the screen, right? So that was a tricky portion. So what we have attacked them with is we have attacked them with uh, dividing the big bulk, basically, right? So you can basically select any component that you have, and for instance, you have in the die, let's say one operation or a couple of operations. Just divide them for the upper die into like multiple different operations or stations, right? Like OP10, OP20, whatever. And then when you are simulating those, we can see the upper die or the lower die divided into those stations. Okay. Now that being said, the reason being that when you do it now or when you are doing it now, the system would highlight quite a lot of entities, or it will have to go through a lot of processing before it can show you the data you're looking for. So now when you divide them, the task can be a lot quicker, right? Now, to achieve that, what we have done is you use this copy and paste component. This allows you to copy all the existing motion parameters from any component and create a new copy. Basically what you see is this is a created copy of it. So it is currently linked with the parent component, and I don't necessarily need to control any of the motion parameters. Basically, what I need is I need to define the geometry on it, basically to divide it. So that's the copy component. So you can subdivide, you can basically divide the whole component into multiple smaller manageable segments, all right? Many times we have customers using generic pod or some others that require a lot of timing inputs. Now, instead of like redoing everything, you just simply use copy and it will save you a lot of time, right? It's creating a duplicate component, right? So once you have created that, now the linked components will give you an association map, basically saying, okay, what component is associated with another component, all right? So that you have like a tree association map or association tree, what it looks like, so that you can know what or how many components that you have modified or kind of copied. Currently, I have like use the default naming convention. Maybe in your case, you would not be doing this, so at least you would know what exactly is being copied. Now, if you were to delete any of these components, you already were receiving a message that, okay, if you are going to remove this, these child components will also be impacted. That still remains the same. So you will certainly get the alerts on that, but this association maps, this kind of adds a little bit more value to it so that you know what exactly are kind of interlinked, right? Uh, one function here, which is also pretty useful, is this motion tracking curve that has been requested in a way, and we found out that this is certainly something that we can use a lot. This is especially helpful, let's say, when you're using your transfer, right? So when you're using your transfer, you need to know where my transfer's extreme points or any point of your interest uh, would be traveling in terms of like this overall operation. For instance, we have the standard directions X, Y, Z, so I can get the highest, lowest points, nearest, farthest points in any directions. Automatically, the system can give you that. Or you can pick your own point. Let's say in this case, what I will do is, just for the sake of showing this, so let's say I pick one point on the fly here. So let's say I just pick this point here and click on add, and I'll hit apply. And what you will see is this is exactly how the component will move when in motion, right? So that's the kind of a motion tracking curve for that point, that how it actually would be moving, right? So depending on whatever motion criteria you have. So if you see here, you can kind of see it from the sidelines, whether it clears your objects or not, sufficient enough or not. So that's the thing, right? So as you can see here, if I zoom in, that's the innermost point for this selection, and that is the farthest most point. So that distance is the clamp stroke, and that is the lift stroke. That's what we can see here. And if you have those like overlaps on any of those motions as well, they would also be shown. So this is kind of a very quick and handy way to kind of see whether actually something is interfering or not, or could be interfering, without having actually even to go to simulation or even collision checking, right? It's just kind of quick and easy way. So you can do it for all different components, or just pick any point, or let the system kind of pick it for you, whatever the extreme points are, right? That's a pretty handy tool for the collision checking, right? That's kind of the first run out of the new functions. And here you have another function here. I'll be talking about that too. So this is another function which controls the motion refresh rate, or basically the motion increment resolution, right? So previously the default resolution for the motion was, or refresh interval was 1. Uh, that was the calculated value. So when we run the simulation, this is what you will see there, right? So with like every 1 degree increment, you can see the simulation, the complete production cycle. Now you can break it down to zero point 0.1 increment calculated values in the NX 1926 and above. So this like zero point 0.1 increment resolution, which is 10 times lower, 10 times actually higher than the original resolution. So you'd get this function or ability in 1926 and above. that's an NX thing, but this like the default one works still. So you can carry on with this one, right? So these are the few different options here. Let me take you back to the simulation here. And in case you have any questions coming up, just feel free to post them in the chat window, and we'll be happy to kind of assist you with any of the questions. So uh, one of the other highlights is the SPM optimization, where you can use this existing program which has some standard template built in, or you can have a standard default template with different component capacities to be filled in that you can input here, or you can also have your own existing transfer templates that you are currently using. Basically, whatever method you are currently using for SPM optimization, you can seamlessly build that into this NX or Dynmik Design platform. As you can see here, we have some common areas here. For instance, what is the transfer kind of X, Y, and Z values, the pitches, the timings, all of that is here. The press stroke, what is that? So with this kind of basic information and I can say plus your transfer capacity information, you can get what your system is capable of. As you can see here, when you kind of run through different numbers, you can kind of see uh, like originally the benchmark SPM. So this was the original. So after my changes, I got the updated result to be 24, which is like a 26% boost. So with those changes based on the capacity what you have built in. So we have different type of transfer systems or templates that you can see or use out of the box. Plus, you can combine your own using what we call as a mapping assist function. So that's also kind of is available for you. And this result window is the one which also kind of gives you an idea based on this calculation prototype template that we have used, that where is the limiting factor for your data. So as you can see here, originally in this kind of example, I started with 19. That was my original. And the Z was the limiting direction. So if I optimize my Z parameter, I could get a better result. That's what I verified here. So the limiting factor then was still in Z, but it was much higher than the previous one. Okay. Now, how would you achieve that in general? You would be optimizing, maybe adding overlaps if they are not causing any collisions, right? So you would be causing those overlaps by modifying like the lift entities. So that's what you would be getting, right? So let me kind of take you back to NX and just to show you that what exactly is doing. Let me hit cancel. Yeah, it's okay. I don't want to save for now. All right. So here, SPM optimization. So these are the two functions that are related with each other. And this mapping assist is kind of linking uh, your data that you would receive from your OEM in terms of how capable your transfer systems are to kind of calculate and stuff. So for example here, uh, we can we can see these standard parameters and also like expanded view curves. I'll be talking about that in a moment, but this is a very straightforward transfer travel curve that we all would be familiar with, right? So currently, if I let's say simply click on update result, and you will see what exactly system is capable of. So it has a limiting criteria in the Z value. So that's the prototype that I'm using. And I'll just mark this as a benchmark value. So this is where I started with just by moving this button. And now I'll make some changes. So I know here, this is kind of, there's no overlap at all between my Z and X move. So what I will do is I'll simply add a little overlap here. So just by the 10-degree on both sides. So moving this on the front and moving this backward. Once I do so, yes, or actually I needed to hit the update result, but we'll do that in a moment. So you can see these update already, right? So let me hit the update result. So once you update this result, basically you can see the results right away, right? So how much the system is capable of. You can do this for all different curves as well. So maybe like you can see here, I have a stop in the Y. So Y moves in, my transfer moves in, stays there, then lifts it up. May not be in the real world, but you can optimize these kind of parameters, right? And you can see here by changing those, like just adding these two overlaps in this scenario, I was able to achieve 26% more uh, based on this transfer that I selected, right? So that's what you can see from here. And we can also see from different template types. So sometimes we have data that is based on whether it is okay or not okay, or rather than just having numbers. So you can have that type of template as well. Plus, you can have a default template where we would allow you to add your own capacities. So as you can see here at the bottom, so you can add capacities of your transfer, uh, add capacities of your transfer and your top shoe base for your velocity and acceleration. So that way you can also build your own template as well to kind of optimize your strokes. So you can verify or calibrate the results by just measuring what you're exactly getting with your current system and see how close it is. And then we can validate those things further, right? And here, this is another thing, like when I hit apply here, it will kind of save my project file. I don't need to kind of see these numbers and fill those numbers back into my project. They actually are interlinked. So whether I enter them here, I enter them in my main user interface, so it doesn't matter, okay? So that's kind of a seamless kind of a link there, all right? So that's there. That's a big thing for you in this enhancement so that you have some reference that you can verify that, okay, you're not just punching any numbers. Of course you won't be, but still you have a reference to look at, right? And yeah, that's what it is. And then we have a mapping assist here. Now that would kind of let you link your existing data, like a spreadsheet data. If you are already using something, then you can kind of join them here and then create your own kind of configuration, right? So that's that operation. If you have any questions, feel free to just kind of put them in the chat window, and I'll be carrying forward with the additional operations. Now, the next big thing here is the collision checking. Now, this is a brand new functionality that we have developed. It wasn't there before. We were using the out-of-the-box functionality from NX. Now, what we have is uh, we have uh, we have picked up on the existing functionality, plus added the required functionalities that we have been hearing for a long while. Then kind of created this kind of interface. So here, what you see on top is on the very right-hand side here. This is one of the requirements that was put in a couple of years ago when we had a workshop as well. So here, we have an export snapshot. So sometimes we had a requirement that we want to export the current motion step, whatever, let's say, just kind of exploded view, right? So maybe you want to show some key step in a motion to someone, maybe internally or externally to the customer. You were not able to do that previously, but now you can. So we have that functionality to whichever step you would go to, you can type in that number and then export that in a snapshot. So you can export that data out into a folder and open that out as the regular NX file. So you can do that with this program. Then regarding the collision checking here, you have the option to specify ranges. Instead of like doing it for the whole cycle, you can specify a certain range of your interest as to what you want to evaluate. Maybe you're evaluating a certain mechanism or a set of mechanisms, then you can just focus on that range instead of like spending the whole thing. All right. Then you have a couple of other options. One is the collision tolerance, where you can specify what doesn't get detected in the collision. But this is mainly, this one is the key here, clearance distance. This is one we have been hearing a lot of requests about. So this clearance distance, what this does is, if for many times, as you can see in this case as well, many times we have the requirement that uh, if we have our transfer, we need to maintain, let's say, a quarter inch, half inch, 1 inch, or 3/4, whatever. So we need to maintain that much distance always. And how can we ensure that we are maintaining that distance? And this is one example here, what you see here, 8261. It is also reported here, 8261 here as well. And for all these kind of clearance zones, that will be reported as soft clearance types or soft interference type. So there are three types of results that are being displayed here. One is the hard, when you have potential actual interference. Then you have a touching, where they are touching but not literally kind of a colliding or interference or kind of a gap. It's kind of a 0-0. And then you have the soft, which is beyond your touching range, but in the range that you have specified. So 1 inch and less than 1 inch, or above the clearance tolerance that you have specified, right? So that's what being kind of represented here. And the system can calculate the minimum distance wherever that is going to kind of creating. Okay, so as you can see here, I have transfer listed here, and there was a distance between the transfer and the upper die. That's clearly kind of mentioned here. All right, that's a big kind of time saver there. And you can see here, when I right click on the result, we have the view result, which will see this kind of display. We can also have this option, which is jump to current angle. So that kind of lets you uh, take the motion, just kind of put you in the exploded view. So take the motion step like you are literally at that simulation level. Okay, doesn't necessarily have to kind of show just those components, but it will kind of put everything in that context, right? So, and maybe the intention is you just want to export that data out. You just want to mention, okay, hey, we have some issue that we're going to need to fix on. That's what you exactly would be doing from here. All right. So export to current angle, view result, and then here we have the resume display. So when you view result, we will focus on just the two components that have been detected under this collision. So in order to get back, you can click on resume display, or you can switch to the next one without having to go to resume display. All right. And then also you have another option. Maybe you don't want to look at this kind of pair. Maybe let's say the stripper and upper die you have verified, nothing is to worry about. You can ignore that altogether, right? So nothing for those two pairs will be shown in this result. It will be put under ignored pair list, right? You can also use like ignore components. So maybe like before even running the collision checking, you can ignore literally the collisions, literally the components from being checked, right? So that's being there. So let me just kind of quickly show you a result, how it looks like. It's kind of just for the time saver. I have one result already there. Now here you can see we have a complete list of this kind of a layout. Plus we have a big list here as well, right? So you can see here. And if you want to see that there is any issue with any part, we can easily check that. And in this case, let's say, let me just close this one. And if you want to see the result here, I can just simply go over there. And let me just see here. And we can see, okay, so I had some gripper fingers, and they had about an inch of a gap there, right? Now if I want to bring them back, resume display, now this is where they were, right? That's where these were. If they are okay, meet your requirements, perfect. You got it good. Otherwise, you can change it, right? Similarly, you can have other type of results as well. Just for the sake of showing it, let me just kind of focus on this one. As you can see here, if you have a hard collisions, of course, this one is kind of different because we are kind of showing it for the pod, the bending. But in this case, if you have collisions between other parts other than the pod, of course, here, then it will be kind of highlighted and shown like this, right? That's kind of a quick and easy way of seeing results, right? That's where you kind of specify your ranges, the clearance distance, and if you want to ignore touching, you can, of course, and check collision results here, right? So that's kind of this quick result. All right. I hope you're still seeing the questions. This is I already shown you, right, the tracking curve. So you can get that result out of the uh, at the main level without having to come to the simulation. Now, this is another application that we have kind of developed in the background, and that is you now have the zero point 0.1 increment that I already mentioned about. So for very fine, uh, so in some areas where you have some complex motion, uh, the one increment is not enough. In other words, what I mean by that is sometimes in 1 degree you are traveling, let's say there is a component, let's say there's a cam that is traveling quarter inch or let's say 3/4, and you have an upper die that is traveling like 20 inch. Maybe 1 degree it is traveling uh, 1 inch, for instance. Now that 1 inch maybe like 1 degree, 1 inch, and in one degree you can have the whole cycle of that cam covered or completed, right? And you may not be able to see the intricacies of it a lot well if you would have done it otherwise. But in those kind of circumstances where the strokes are very large proportionately for the parent than the child, then the 1 degree increment is not enough. That's why we have the support for zero point 0.1 increment, uh, which is the calculated value, and you have to have the NX 1926 and above. And once you do so, you get 10 times the resolution. Basically, now you're not just getting a 1 inch travel in 1 degree. Basically, you're getting zero point 0.1 degree for zero point 0.1 inch travel, right? So that you have more action to visualize, right? So that's what this is doing. This is all in the background. You get to choose what increment, what refresh interval you get to choose right at when you're initializing your project, or when you are in the motion simulation even, right? So you get to, like, I'm going to say the dynamic design component. You get to choose between both of them, right? So that's another enhancement. Let me also, before I kind of summarize this again, let me bring this last document here to show you a few extra things that I haven't kind of included in the presentation. Those are some enhancements in the expanded view, all right? For instance, we have seen all of this. That's all done here. Okay. This is one. So you may have seen some of you may have seen already. This is our initialize project, how it looks like. Initialize project view, where you kind of specify your macro settings of your project. Then you have a license management here, as you see, like where your licenses are located. So you get to see that, and also you have a centralized settings location as well. So you can specify with a certain environment variable, this one, that where the common custom settings of Dynmik Design die are located, all right? And they may be including your default values that you want to begin with always, or you have component group customization. Maybe you want to create a new standard components groups. So that's another thing, because all of the components that are listed in our Dynmik Design, they're kind of standard components, but you can create a duplicate copy of it and call it a new component as well. That's a group customization here. And you can have specific component names too, based on the kinematic model names as well, right? So that's kind of customization. You can put it in a central location where everyone has access to, right? So that's another setting there. And this is another one. So another expanded view of where you see these curves. You get to see the control points, of course. This was there before. But you have more control points for other hydraulic components too. Then you can just simply gonna click on these components and move them around easily, or you can do that from by typing in numbers as well. That's kind of done it. Then you have, these are the new ones. So you have the XYZ values here, and actually by the time you get the release, you will have ABC for the rotation motions as well. So you get to choose different component groups, different individual components directly from here without having to go back to the program itself, because this is kind of very valuable kind of information. All right. You also have zoom functions for checking out on some tight curves. So these are like stripper and lifter curves. So how they are synced together, you can kind of zoom in on certain areas to kind of see the motion curves a lot better, right? Plus, you also have another thing that allows you to have, let me see, actually up there in the beginning. So you get to install software. If you have multiple NX versions, you get to install on all of the NX versions together, number one. Plus, you get to install using a command line. So that is for the IT people, so who are interested for maintenance tasks. So we have a silent installation that runs with the command line in the background, so that can be done easy for maintenance. Plus, of course, like I've already spoken about, a centralized settings area to kind of define custom environment for all the users, right? So, yeah, I think with that, I will kind of summarize with this. So what you have looked at, we have looked at some of uh, the the UI related changes or improvements. There are many others in the background. I didn't kind of brought up a lot in this moment, but there are certainly some in the background. Then the key highlights were strokes per minute optimization, collision checking, and uh, associated function that helps with the collision checking, right? Uh, so yeah, that's pretty much it. So maybe with that, I'll like to pass it back to Phil to see if we have to follow up with the next segment of our presentation. Phil?
Absolutely. Thanks so much, Taking. Can you hear me okay?
Absolutely. Yep, I can.
Absolutely. Okay, great. And you can see my screen. So, folks, now we're going to move into the section here of, getting the conversation going and maybe sharing some experiences here of the software. So, yeah, to get things going, if anyone wants to type in a question into the chat or use the hand raise or just even unmute yourself if you have anything, any questions, comments, especially if you're a current user of it as well, like what you see in these changes and what you feel like they might mean.
What is the chat?
Hmm? Sorry, was I?
Hello?
Hello.
Yeah, I think you can put that chat icon
Yeah,
there.
I
So
don't see the chat. If you, oh,
Oh,
maybe
the
so if you
yes.
can switch to that.
Sorry. Yeah, sorry about that. Let me just show you here what the chat icon can do. So you can use this icon here to put it into the chat, and then there's a hand raise button as well, or you can just click on the microphone to unmute yourself. So I think I hear somebody.
yes.
Yep.
Actually,
Hello.
yeah. Hello, hi. It's Mohammed here from ABM.
How's it
Uh,
going?
oh, not bad, not bad. I just get a question for you. Is your software taking into consideration the acceleration or the inertia, total inertia of the system in any way? Like if you have a
We
high acceleration, is it that get considered or not?
uh, maybe I can answer that. So we do have a program in the background that does allow you to take those into consideration. We have a program called velocity and acceleration analysis in the background that you can evaluate whether those kind of meets your requirement. From simulation point of view, simulation, it doesn't take that into consideration. It's just pure motion simulation without having those the mass related motion. But that is actually built into a context like we have a cushioned motion to begin with. So you still have some impact, but not, you cannot just fill in, oh, I have this much mass and then it should slow down or speed up, right? So you don't have that to impact the motion directly, but you do can analyze.
I see. Okay, thank
Mhm.
you.
Anyone else with questions, comments about what you've seen in these new features and what you think they might mean for you, or yeah.
Actually, that's Mohammed again. I have another question for you. we new to the software, so we don't have the NX. So I'm going to ask just, is that the module for the transfer kind of simulation, is it, you have to buy NX plus the modules, or how that work? Like it's, and the other thing is it like network license or a standalone software?
Maybe Phil, maybe you can answer that easily. Would you like
So
to answer that?
So the first question was needing, so with, you would need NX to run this software, correct? And you also need the like the Die Wizard application, which is what it's built on top of, and it's pulling some of its power from. And then with that, sorry, you were saying that the second question was about license?
Yes.
So we offer it on a subscription license. And
is it a network license or a standalone by like individual computers?
Network.
It's a network license, yeah.
Network. So any user can basically open it.
Yeah. Yeah, you would be purchasing like a concurrent seat. Yeah.
I see.
One thing I actually did kind of promise to get back into actually later in the presentation was to talk a little bit about something I mentioned at the very top, which was this idea of looking at your whole design process when you use this software, and something like, designing from strip to transfer to die, rather than die to transfer. And Ruben, I think Ruben's here with us. Ruben Greenhouse, are you able to speak a little bit to, because this was something you mentioned last time I spoke to you, and it seemed pretty relevant to this conversation. I was wondering if you wanted to talk a little bit to that.
Yeah, thanks, Phil. This is Ruben Greenhouse here with LTS as well. What I found was that it's, if you design your transfer up front, it's fairly fast to simulate it now with all the new tools that we have in there, and that it's getting it easier and easier to design your transfer before you design your die. Before, it used to take a long time to do stuff like this, and you'd have to wait till the die was designed and almost finished and almost built before you design the transfer. And then you run the collision checking and you find a whole bunch of collisions, and then you have to get those cleared on the die, and the die's got to go up on the mill again. It's got to get stripped all down, and it's just not the best way to do it if you can afford to do it up front. Doing the strip and then the transfer, then the die. That's the best process. I'm not sure how many people follow that rule. I know it doesn't happen often enough to get the opportunity to do the transfer first, but that's kind of the preferred method. And we got some great tools now. The tracking curves really help you with that, and then the collision clearance distance really helps you with that as well. Yeah, I think there's some really good tools there now.
Yeah. Yeah, thanks, Ruben. Thanks for that. Yeah.
Again, that's Muhammad again. I just have another question for you guys.
Mm-hmm.
And basically, your system also allow for rotation, finger rotations, and give you start end kind of rotation angles, stuff like that?
Yep. Absolutely.
Okay.
Absolutely. So part rotations, free drops. We can also kind of simulate robotic pickups if you, we have flexibility. So yeah, absolutely.
Okay.
I know that we haven't shown the simulation, like a complex simulation yet, but definitely, yeah.
Okay. Also, there is another function in some transfer that you can just front and back kind of bars just moving kind of separately, like each one has its own curve, if that can be simulated in your system.
So let me just confirm. So you're asking like if you have two transfer systems with different pitches, is that what you're saying?
Not two transfer systems, one transfer system, but the front bars and the back bars just moving in different curves or different.
Yeah, absolutely. Yeah. Absolutely. You can control that differently. No problem at all.
So you can control the front and like, it's not like coming with, okay.
No, not at all. You can work on that independently. Plus you can have, so this is one way, like a front and back. And then other examples too. Maybe you have some parts being transferred from one type of die to another type of die that can have different transfer pitches too. So that can also be handled and instead of like just front and back. We just kind of aid in the beginning, like you can have like both of them synced. You can de-link them. You can have different sets. You can have 4 sets, 5 sets, 6 sets, whatever. So you can have as many, that's flexible.
So it's flexible. Okay.
Yep.
Mm-hmm.
And
You
that
can have it.
yeah,
Yes.
go ahead. No, sorry, go ahead.
Yeah, okay. You can have as a as I was explaining in that copy component too. You can not necessarily just copying component, but you can add in like independent upper dies, lower dies as well, just to explain that kind of a stamping sequence as well.
I see.
Right.
Okay.
Go ahead. You had a question. Yeah.
Thank you. Yeah, I just actually I forgot what I want to ask.
Oh.
No, I forgot what I wanted to say. Yeah, I'll
Sorry
just
to
move on.
interrupt at that time.
No, that's okay. That's okay. It's not a problem. Yeah.
Okay, we've got a few minutes left. I'm still happy to hear about any questions like in that respect. But another area here we were interested in looking at was this area, which is new pathways toward enhancement. And so this is something more along the lines of something like your wish list, or is there anything, whether you're new to the software or a consistent user of it, is there anything else that you really want to see? Because at the end of the day, these changes that you've seen here today, these are almost all directly driven by, I'm going to say they all are directly driven by questions or requests from die shops themselves. So if there's anything you want it to be able to do, we'd love to hear that as well.
That's a different related question, but is it, we can use the software to try to mimic or to simulate progressive tools also, or just only for transfer?
Oh no, progressive, transfer, hybrid, stamping, all sorts of stuff.
Mix, progressive.
Yeah, absolutely. Yeah, mix anything, doesn't matter.
Mm-hmm. Yeah.
So transfer was just an idea, so yeah.
Yep, absolutely. Yeah. I really appreciate all the questions, Mohammed. You're carrying me here. Okay, Peter B.
I'm sitting with my buddy Flavio here, so we keep both of us kind of same question.
Yeah. Peter, how's it going?
Hello, microphone?
Yep, we can hear you.
All right. So the window where you're assigning the components, I guess, well, for me it's the second button, as I remember. But when you hit escape and that window's open, it just says, would you like to save, yes or no? Can you make it so it's, would you like to save, yes or no, and then like cancel, I don't want to close the window right now? You know what I mean?
I know, I know what I mean. Yeah, I know. Actually, yeah, I know. I think this was a discussion I had a while ago when actually we kind of were discussing it. But actually, that's a good point. Let me kind of revisit that. There was some limitation at the time from NX side, I think, but with a newer program. I haven't kind of followed up. I think I got used to it, but I think that's a good point. I need to kind of come back on this. So you guys actually can look into it. It's a very good point. Yeah. But I know what you're talking about, for sure.
Yeah. Sometimes something else is open, you just hit an escape out of frustration. You're like,
I know. I know.
Yeah. No, we'll put it at the top of our list. A cancel button for Peter.
Thank you. Put a little annotation on there with my name on it.
Yeah, that's right. Yeah. Absolutely. Okay. Thanks so much, Peter. And we've got a couple minutes left. Any other thoughts, questions, big priorities you've got right now in your die design, pain points even things that, if you had a magic wand and could make something go away, what would it be?
I think since we are waiting, maybe I can just kind of quickly share something as well.
Mm-hmm. Absolutely.
So that might actually also kind of share that what we have previously planned to. And that is in regards to collision checking, SPM optimization as well. So mainly like with SPM optimization, because that is one of the big topics for sure. And in the newer releases, I would say, we will be targeting on different advancements with this approach. We currently have motion parameter based. That's where we currently are using. So it doesn't take into effect your actual geometry unless you kind of do the collision checking, of course, right? Because what it will do whatever numbers you put in, right? So of course the next obvious step for us is to kind of take the geometry into consideration and be able to see what exactly it can do, and eventually be able to give some recommendations as well. Okay, so that's kind of the vision what we are looking at. It's not just okay, yeah, just punch in some numbers, see some numbers, all good. But that's not just the intent. But our intention is to kind of proceed it further and carry the development in that direction.
Mm-hmm.
So that's certainly something big that will be coming as well.
Mm-hmm. Yep. Yep. Very nice. And Peter. Yep.
I thought of another thing.
Oh, nice.
So I'm gonna wait. Don't worry. In the same window where you're picking your components, so you pick your transfer bar 1, you put in all your motion values, yada yada yada, hit OK, and then you pick your transfer bar 2. It automatically links and mirrors those movements to to transfer bar 1. But then when you go back to open transfer bar 1, it then links to transfer bar 2, and then you can't change them any of the values anymore until you delete transfer bar 2.
Mm-hmm.
Is that something that's just mine's doing? That's not
so it should be changing. So the standard is basically I can actually you can actually text. Do you have the email? I think you will get after we kind of get towards the closer. You can actually just send a quick email at that, or maybe just add the support at Long Term Tech. I can actually have a look at your session, but that shouldn't be doing it. So the technically thing is that simply it just kind of applies across, not just to a transfer. So wherever the component is linked with, so the parent component is the controlling one. Okay. Whatever is your transfer 1 is your parent component, so you're supposed to make the changes from there. But you can actually also make the changes from the transfer 2 as well. So I can actually look at your system and see what exactly is going on, but that shouldn't be the case.
Yeah, pretty much once I have both the bars set up, they link to each other in an eternal loop of stuck with each other.
That's fine. That's fine. I understand what you're talking about. I can certainly have a look at with you. Just we can follow up.
Okay, sounds good.
Yep. Thanks for bringing it up for sure. Yep.
Very nice. Well, that takes us back to the top of the hour, the top of the next hour, and it's been thank you very, very much, Peter and Mohammed, for the questions. And with that, I think just in respect to time. And by the way, if any of you want to reach out to us at all, let me just actually make sure that we bring this up. I'll just bring this up here if you want to get this information down. But like I said, we're recording this, and you will receive a recording of this session as well to distribute however you like, or to refer back to. And anybody who is looking to get in touch with me to just set up some further conversations about this, or learn anything more about what we do or how we can help, there's my contact information right there. So thank you all very much for joining. And feel free to check out our website too at www.longtermtech, that's TEC.com. And thanks everybody for coming, and have yourselves a wonderful day. And thank you, Chetan.
For sure.
Absolutely. Thanks, everybody.